I'm Ira Flato, host of Science Friday, and your host for this tour of Mars. All buckled up? Let's begin. Until the invention of the telescope in the early 1600s, Mars was only a ruddy heavenly being that appeared to wander against the background of fixed stars. It wasn't until the late 1800s that telescopes had advanced enough for Giovanni Schiaparelli to create the first detailed map of Mars seen here. He was the one who named what looked like seas and continents, and even canali, mistranslated from Italian as canals, but really meaning channels. Shortly after Schiaparelli penned his map, working over a period of 15 years, Percival Lowell created his own improved map, observing the red planet from a place called Mars Hill in Flagstaff, Arizona. Antoniadi published a more detailed map in 1930, with corrections to some of Lowell's place names and adding some new ones of his own. It was he who dispensed the notion that Mars had canals, saying they were merely optical illusions. The U.S. Mariner and Viking orbital missions of the 1970s were the first spacecraft to systematically map the planet and provided the global view you see here, although when Mariner 9 first arrived, the planet was shrouded in a global dust storm. As the storm cleared, the first things seen were the tips of the massive Tharsis volcanoes standing above the clouds. As you can see in this global topography map provided by the MOLA instrument aboard the Mars Global Surveyor spacecraft, these volcanoes are huge. They tower 20 kilometers, 65,000 feet tall. That's 3 times the height of Mount Everest. By the way, you see those little green hiker icons? You can learn more about the Tharsis volcanoes and other places on Mars by just clicking on the green hiker icons wherever you see them. They're excerpts from Bill Hartman's A Traveler's Guide to Mars book. Next stop on our tour is Olympus Mons, right here. It is the largest volcano in the solar system. Its base would cover the state of Missouri. But just like other volcanoes, Olympus Mons is just a pile of lava flows. The volcano kept erupting in the same place, building the lava higher and higher. Olympus Mons and the other Tharsis volcanoes are very broad with low slopes and are classified as shield volcanoes. The largest one of these shield volcanoes is this one, the Olympus Mons. You know, you don't have to go to Mars to see shield volcanoes. They are just like the ones in Hawaii. In this high-rise image draped over HRSC terrain, we can see the evidence of lava flows on the eastern flank of the volcano. Each of these high-resolution images has their own detailed information written by the science team that operates the cameras. Now, you may be wondering why the high-resolution imagery is mostly black and white. That's because the cameras that take these images sacrifice color for resolution in their hardware design. The context camera, which you'll see examples of later, is only black and white. The high-rise imagery is mostly black and white, but has a color strip running down the middle of the image. This is not the true color a human eye would see, but false color. The detectors that help build this color information view Mars in a different part of the spectrum than human eyes would. This false color is valuable because it illuminates the distinction between different materials and textures. Lava is not the only thing that covers the volcano. The pervasive Martian dust does too. It has been deposited on the volcano's flanks for millions of years, and much like a dense snowpack on Earth, when enough dust gets oversteepened, an avalanche can happen. And this dark-looking streak is one of those avalanche scars, and we can even zoom in and see a large boulder about the size of a delivery truck that the avalanche skirted around, leaving a wake of undisturbed dust in its lee. Also in common with the Hawaiian volcanoes, Olympus Mons has a steep flank that surrounds part of its base where material has slid away in giant landslides. This scarp is 1.5 miles tall. At the summit of the volcano, along the rim to the left, you can see some clouds that were captured when the image was taken. We can see several nested circular depressions called caldera, which are collapsed features that formed when the magma chambers cooled or drained, similar to terrestrial volcanoes. Along their rims, we can see layer upon layer of volcanic rocks exposed. It's just the topmost stack of lavas that make up the gigantic mountain. The other thing that Mars has the biggest of is canyons. And this one is really big. The Valles Marineris Canyon system would stretch from New York to Los Angeles if it were on Earth, and our own Grand Canyon, it would be nothing more than a minor side canyon. Calling it a canyon system is actually incorrect because water did not carve these features. Instead, a process of rifting and collapse created this giant scar on the planet, similar to the East African Rift in Kenya or the Baikal Rift in Siberia. In some places, the jumble of rough blocks on the floor of the chasma is a landslide deposit, where the chasma wall has collapsed. The Valles Marineris shows evidence for an awful lot of rock moving around at all kinds of scales. The Horst and Graben structure of the long linear portions of Valles Marineris are indicative of large crustal blocks moving apart and dropping down. This high-rise image shows strike-slip faulting on the floor of West Kander Chasma, just like the San Andreas Fault in California. The thin line in the middle is the fault, with the ground on the north moving to the right and the ground on the south moving left. There's actually a lot of faults in this area, with the crust faults in a brittle fashion. There's also soft sediment deformation, where the rock layers look like they have been bent. When you get a chance, come back and spend some time looking at them, or even pause this tour and take a look around. Even though water did not carve the Valles Marineris, many scientists think that it was very active here, and their primary evidence are these layered mesas and deposits that can be found on the floors of the chasma, and even in some cases on the plateau above the rims. This is Juvente Chasma, a satellite depression of the Valles Marineris system. It has these light-colored layers on mesas in the chasma and on the plateau rim. We don't have time on this tour to have a look at them, but hey, you can come back and look at these high-rise images later on your own. We're going to turn on one of the Contax camera overlays for you. Many CTX placemarks have a load this image link in their information balloons that can be clicked on to bring up an image overlay. This little mesa right here on the floor of Juvente really shows off the regular layer cake-like structure that tells geologists that sedimentary processes probably built up these rocks over the slow course of time. These layered units, with this sedimentary look to them, they're littered all over the Valles Marineris. Of course, since we can see them, it means that not only did an enormous amount of time pass to build them up, but also a whole lot of material was excavated so that we can see them exposed on the cliff sides. Well, that's about all the time we have for this tour. Went by fast, didn't it? The good news is that you don't need me anymore. There's plenty of Mars to explore on your own. So have fun, take your own tour, right here on Google Earth. I'm Ira Flato. See you on Science Friday.